the practice problems that we're going to do is probably the most difficult. So the lattice energy is the energy to break up an ionic solid. There was a whole video on relating that lattice energy to Coulomb's law, so you might want to go back and watch that before you watch this, or even watch it after. So with Coulomb's law, we had explained that these Q's are related to the charges, and for ionic solids, we have opposite charges attracting each other. These charges can have different magnitudes to them. So the larger the magnitude of these charges, the greater the force. So these are directly proportional to the force that's pulling those cation anions together. And then for the distance, which for what we've been talking about is the distance between the two atoms, which is related to each of their atomic radii, so how close they can get to each other based on how big they are. So the smaller the atomic radii of the cation-anion pairs, so if this is smaller, they're inversely proportional to the force. So the smaller the radii of that cation and anion pair, the more force that's going to be put on drawing those two ions together. So this whole thing, this whole part is electrostatics, and it has to do with charges and distances, but for us it's going to be how big the charge is and the radii between the two parts of the salt. So typical question, and this one's on the quiz, which is why I wanted you guys to wait to take it, until Monday, unless you understood it. So we're going to order these ionic compounds in increasing lattice energy. So we're going to look at the lattice energy in terms of force. And when we say something is increasing or decreasing, to put them in that order, I think it's a good idea to write down what they're looking for and say to yourself, if I'm putting them in increasing lattice energy, the one that I put to the far right has the largest lattice energy. The largest lattice energy is because the stronger energy that it takes to break up that solid is going to be the highest force in between those two. And then we have the two criteria, which is going to give us that relationship between the force. First thing you want to do, and the one that has a larger contribution, is look at the magnitude of the charges. So for each one of these, and this is good to go back and refresh that there's charges associated with each one of these cations, depending on their group on the periodic table. These two have the larger charges. So for these two, so these are 2 plus with fluoride, this is 1 plus with fluoride, and then we'll compare those two afterwards. Of these two, so this is greater force. Than those two, and again, because they're higher charges, more force. So we know we're going to put those two over here on the largest lattice energy, and then to differentiate between those two, they're both paired up with the fluorine, which is the fluoride ion here. So we have to figure out, of those two, which one has the smaller radii, because that's going to be the one that has more force. So then if we look at calcium and barium, the radii is increasing as you go down a column. Since calcium has a smaller radii, it's going to have the greater force. So that's why we're going to put that one farthest to the right. So these two come